For our Microsoft Azure storage triggered event, we are going to build an application that is triggered by an addition to a queue. So when it gets triggered, when there is an addition to a queue. To continue with our food theme. So in the previous example, there was a Twilio notification, like send an SMS, and it was like a food delivery thing. So we'll continue with that. All right, we will build an order queue. So the food orders, like the fast food or something, when they order, it goes in the queue. We will build an order queue that will store orders for delivery as they come in. Once an order comes in, it will get stored. Why? So it gets read by someone else within the team to get prepared and fulfilled. All right. When a new order is added to the queue, we will update our queue and create a post to our previous function's URL. We are using a queue in this application because it makes sense in the context of delivery. Because you have requests, so it makes sense that you have a line, you have a queue, right? However, there are several storage triggers provided by Azure, including, so not only triggered by addition on a queue, there are several ones. There are several storage triggers provided by Azure, including Azure Blob Storage, storage tables, SQL tables, no SQL database. I recommend looking into these other options after our queue demonstration. So after you see this video, after you apply what you see, we are not applying here. We are skimming a book. We are just browsing. We are going fast. You can listen to this channel while driving, while relaxing. You can increase the speed to 2x speed. So the 20 minutes becomes 10 minutes, so the 12 minutes becomes 6 minutes. All right. So this is not really a study, it's a skimming, it's a browsing, it's going through the book. All right. Which is useful if you want to have a general look. You don't want to know every single detail. You don't want to apply it, but you want to manage it. You don't want to work on it, but you have a team that you would like to understand what they are doing. All right. While the Azure storage options are similar to those in AWS, there are some differences in the way they are set up and accessed. It might be a good idea to read back through chapter 3, AWS, right? And try to implement our application that we created in AWS in our new Azure environment. So do what you learn in Azure in AWS, and do what you have learned in AWS in the Azure, vice versa, right? This way you can get familiar and you can master your work. Azure Queue Storage. Azure Queue Storage provides cloud messaging between application components. Again, Azure Queue Storage provides cloud messaging between application components. In designing applications for scale, application components are often decoupled so that they can scale independently. Why they became them not related? So they can scale independently. So you can enhance each one independently. Queue storage delivers asynchronous messaging for communication between application components. Queue storage delivers asynchronous messaging for communication between application containers, whether they are running in the cloud, on a desktop, or on a premises server, or on a mobile device. Queue storage delivers asynchronous messaging for communication between application components. All right. Now, queue storage also supports managing asynchronous tasks and building process workflow. Figure 431 is an example provided by Azure to explain components of a queue. So let's go to 431, like this one here. Illustration of the queue storage that Microsoft Azure provides. So this is the storage, account storage. This is my account. This is a queue. Images to download, images to resize. Okay. The example uses an image resizing application that is dependent on order. The queue service contains the following components. What does the queue service contains? It contains the following components. Let's go through them. The first one, URL format. Similar to functions, queues are addressed using the following format. So functions are accessible through a link, through a URL, and the queues are accessible in the same way. How to do that? It's written like this: http:// storage account, then /queue.core.windows.net/queue. The following URL address in the queue, figure this. This is an example. So this is the first component URL format. The second one is storage account. All access to Azure storage is done through a storage account, all right? The third one is a queue. A queue contains a set of messages. All messages must be in a queue. Note that the queue name must be all lowercase. And the message. So 4 components: the URL, the storage account, the queue, and the message. The message in any format of up to 64 kilobyte. The maximum time that the message can remain in the queue is 7 days. So the queue is not permanent, it's just temporary for 7 days, right? And what is the queue? It's a Microsoft service, right? Azure queues are fairly easy to set up and understand, so I enjoy working with them. The drawback to queues is the lack of control with the columns and rows. Rows will leave the queue as soon as they are executed, and you only have one message colon, which is the message being sent. The colon you get from Azure The colons you get from Azure are the ID, insertion time, expiration time, DQ count, and size. Create the function. We are going to return to the Azure portal to create our storage function. So we need a storage function, right? To do our example. That works, that triggers when an addition happened to a queue, right? That uses Microsoft queues, right? It's implemented using Microsoft Cloud solution that is called Microsoft Azure. All right. To create our storage function, navigate back to the New Function section and select the queue trigger, JavaScript template, figure 432, leave your storage account, connection as is, and change the queue name to whether it makes sense for your queue. I choose orders because my queue is going to be a collection of order. And here's the thing: create a queue trigger function in node.js. All right, functions app functions. When you go to that, queue trigger JavaScript, a JavaScript function that will be run whenever a message is added to a specific Azure queue storage, right? And you name the function here, and the queue is orders. So the name of your function is storage, the queue is order, and the connection Azure Web Job Dashboard, right? I name my connection storage to separate it from other functions we have already created. Creating this will give you a stubs out queue function that you can test using the test box on the right. And you have a text box on the right. All right. You can create a test message and run it to see that it works. However, we haven't set up our queue yet, so we will need to do this. To get started, click the documentation tab at the bottom of your integrate blade, and let's go. And here is that's shown in figure 432, just like this. Get the account key. 433, yes. Get the account key and the connection string from your integration documentation. Account key and connection string. All right. Let's go back and see what is this note or hint. This document tab or documentation tab that is mentioned here. To get started, click the documentation tab at the bottom of your integrate blade, right? There is a hint about that. This documentation tab is actually fairly useful for getting started or any new function. Azure provides this documentation for the functionality of your trigger and function within your function. It makes it really accessible and limits the time you would have spent searching through the Stack Overflow and Google. So you can search in Stack Overflow or Google, and it looks like you don't have to search in the GitHub. And the documents provided inside the function is helpful, and that's the documentation tab. All right. This documentation tab contains an account name, account key, and connection string for your function. You will use the account. Yeah. We are going to create our queue using Microsoft Azure Storage Explorer. We are going to create our queue using Microsoft Azure Storage Explorer. So how we are going to create the queue using Microsoft Azure Storage Explorer? You will need to download this tool to be able to use it. So we have to download it first. We will discuss a little more about Azure Storage Explorer before jumping on it. So let's go through Microsoft Azure Storage Explorer. We will be using Microsoft Azure Storage Explorer tool to access and manipulate our data. Microsoft Azure Explorer in preview mode currently is a standalone application from Microsoft that allows you to work easily with Azure storage data on Windows, Mac OS, and Linux. So it supports these operating systems. What is it called? It's called Microsoft Azure Storage Explorer. What is it? It's an application to be downloaded. It's a standalone application. Who made it? Microsoft made it. What does it do? It allows you to work easily with Azure storage. All right. To install to this tool, go to this link and click the appropriate. So this link helps you to install it. And click the appropriate download package for your machine. What is the link? It's http://storageexplorer.com. Again, http://storageexplorer.com. Once Storage Explorer is downloaded, you will need to connect to Azure Storage. Click on third option provided to use storage account name and key, and provide the credentials that we received from the portal earlier. Figure 434 shows what your storage attachment should look like. Just like that. All right. Name and key. Use the account information from the connection to our Azure storage. All right. Click through the rest of the setup, and this will form the connection to your Azure account and your various storage applications. When the connection is formed, you should see your application listed under storage accounts and should see options for queue, blob containers, file sharing, and tables. When I first started, I was assigned an Azure machine learning project that used data from an SQL database. One of my first tasks was to host this data in Azure, and I did this through SQL Server. It was an absolute nightmare, so the author didn't like it. This tool is actually very powerful and lets you easily manipulate your data in one spot. The only thing that is a little hard is that it is an entirely new tool you need locally to access these capabilities. I would prefer for this tool to be hosted in Azure, but this can be subject to change, seeing as how it is just in preview mode now. In the meantime, this is what I recommend using when you are interacting with Azure Storage. Under queues, right-click and choose Create Queue. Give it the same name and you gave it in the settings of your Azure Functions, which is order. We name the queue orders. We can test the template function by clicking Add Message and adding a message to your queue. This should trigger our function. Then remove the message from the queue. Figure 435 illustrates what our queue should look like. So this is the queue. Right? When we add a message, it triggers something. For my test message, I just provided the queue with a text and sent it on its way. Just added text. We can go back to our Azure portal and check the logs of our function to make sure our message was sent and received. If it was successful, you should see a message like the one shows here, 437, success log from our queue test. So let's go through that. Function started, function completed, all right. JavaScript queue triggered function processed work item. I like to order some mac and cheese. So this is the one before the last, all right, and says function completed, success. So it did trigger something. That's success log from our queue test, all right. If we have confirmed that our queue is connected to Azure and is triggering our function, we can move on to complete our index function and package.json files. So we still have to do the index, the function, and the package.json file. Let's go through the function, finish our function. To write our function, we are going to use our HTTP post endpoint from the previous exercise to post a request order to it. If you remember, this URL was like that, right? We will use the node request package to serve this request. To do this, we will have to create another package.json file and include it in our dependencies. My package.json looks like this, and it shows here. And here. We need to upload this file to our project and our Azure application. Then we will need to return to our Kudu dashboard and do an npm install. Again, we go back to kudu and do an npm install inside our project folder to make sure the right node modules are included in our application. Once this is completed, we can go ahead and finish out our function. The request node module is designed to be the simplest way possible to make HTTP calls. It supports HTTP and follows redirects by default. The first argument can either be a URL or an options object. The only required option is the URI. All others are optional. So the URI or URL, fully qualified URI or parsed URL object. Base URL and method and header are all optional, right? For the information on the request module, go to this link. So if you need to learn more information, go to this link. Following the described request parameters, we will create an option JSON with our own values filled in, and we will set JSON variable to be our incoming myQueue item. Listing 4.2, which is this one here, shows a built-out function for handling queue requests and sending them to our next function. So this one, a function that takes in a queue item and submit it to our HTTP function. So takes in a request, and does this if then, yeah, just like that, and else here. All right, once we deploy this function, we can test it once again, creating a message in our queue and submitting it. If all is set up correctly, we should be able to go into our logs for both storage functions and HTTP function and see our message come through there. You should also continue receiving text for each message you create. If you are having trouble seeing your changes, make sure your endpoint is correct and that your queue name is the same in Storage Explorer in Azure. Configuration is more likely your issue than something in your code. These are the two places where the configuration really matters. Another thing to keep in mind is that the way we set up our HTTP function was to receive a body and a post request with a specific structure. The structure was name, order, phone number. So our HTTP function, to be able to handle our incoming queue message properly, one of two things must happen. Either we must structure all queue messages as if they were JSON objects and make sure each item contains name, order, and phone number, or we must rework our HTTP function to accept messages as string and send that message directly. I choose to structure my queue, so the first one, as JSON value to test and make sure the message makes it all the way through the flow. After adding the initial message, I first went into my storage function and checked the log to make sure it received and sent messages. Figure 438 shows my results, and here's the result, and the logs shows that, which is down there here. After confirming that the message made made it to step 1, I looked at our HTTP function log to make sure it made it through step 2 as well, and we can see it made it through step 2 as well. Shortly afterward, I received a text message with the message I had added to the queue. As you can see, it's pretty quick and easy to set up a storage trigger function in Azure, especially using Storage Explorer. The food delivery notification system is one application of the storage as trigger, but there are many more you can add to your function. For this exercise, we are going to restructure our application process flow. The HTTP request will now be step 1, and the storage event will be step 2. So it's backward, right? We will continue to use post request to our HTTP function, but instead of sending a test, we will update our queue with the parse message we want to send. When this message is added to the queue, it will trigger the second Lambda function that will send a text to customer. This will give you exposure to manipulating queue data in Node in Azure Functions. If you wanted to take it a step further, you could even look into blob storage and add images to the storage to send those to the user as well. Azure's blob storage is very similar to AWS S3, which we used in the last chapter when we studied Amazon AWS cloud. All right. Common uses of blob storage includes these. These are the common uses of the blob storage. Let's go through them. What are the common uses of blob storage in Microsoft Azure? The answer is they can be used in serving images or documents directly to a browser, in storing files for distributed access, in streaming videos and audios, in storing data for the backup and restore, disaster recovery, and archiving. It can be used for storing data for analysis by an on-premises or Azure-hosted service. So the blob storage in Microsoft Azure is similar to the S3 storage in the Amazon AWS. All right. The following diagram should give you a better understanding of how blob storage works in Azure. So we have, and here's a learn more link, okay? So we have an account called, then a user called Sally, and we have container with pictures and movies, and we have a blob storage. This images goes into the picture container, and this movie goes into the movie container. The chapter's conclusion in this chapter, which was about Microsoft Azure. In this chapter, we explored HTTP triggers and storage triggers in Azure Functions. We looked at some differences between developing in Azure and developing in AWS. So we compared solutions from Amazon that we studied last chapter with Microsoft solution, which is Microsoft Azure, Microsoft Cloud Solution, which we covered in this book, and we compared them, and we discovered lots of differences in the process of creating functions. We looked into webhook and HTTP requests for API triggers and saw how we could use either in daily applications. At this point, you should feel comfortable writing Node functions and deploying them in either AWS or Azure. You should have better understanding of the Azure configuration in comparison to AWS, and you should have clearer idea of why you would prefer one vendor over other. In the next chapter, we will continue building serverless applications. We will look at Google Cloud and build out a couple of cloud functions, explore the user interface, and continue to analyze differences in vendors. See you then. Have a good one. Bye.